the ramp response of first order system. So the analysis is similar. So we take the transfer function C of s by R of s is 1 by 1 plus st. So in this case your R of s is 1 by s square for unit ramp. For simplicity purpose we can take a unit ramp which is 1 by s square. So what will be the C of s? C of s is 1 divided by s square into 1 plus st, and we can write this C of s as a by s plus b by s square plus c by 1 plus st. Then we can easily find out what are the ABC values. Then we will get a value is capital T and b value is minus 1 and c value is t square, capital T square. So therefore we can apply inverse Laplace transform here and we can get what is the time domain expression, that is C of t. So what will be the C of t? Capital T by s will be capital T minus we have 1 by s square which means small t plus, so we have t square by 1 plus st. So we can take common t here so that denominator you can take t common and numerator 1 t we can cancel them. The remaining will be t into e power minus t by t. Therefore the finally your C of t expression will be capital T minus small t plus capital T e power minus small t by capital T. This is the complete response of the system when unit ramp is given to you. Now, so out of this response we know that t e power minus t by t is the transient term and capital T minus small t is the your steady state term. So we have both steady state as well as the transient. Now this equation if you plot it, how the plot would be? So I have C of t and I have the time. So when you plot this, first of all I will plot the input. My input is ramp. So this is my input ramp. So as input is increasing, then your output also increase, but the shape of the ramp input, the shape of the output is going to be slightly exponential increase. Then after that we have again parallel to the ramp input. Now so from this it's very clear we have very small amount of transient response and we have a large your steady state response. And again if you take the steady state error, what will be the steady state error? A of infinity is R of infinity minus C of infinity. What is R of infinity? We know what is R of t. R of t is a small t, okay, because it is unit ramp. What will be the R of infinity? Then t will be infinite. So we need not take that R of infinity. We can take it as E of t as R of t minus C of t. So what is E of, we'll take R of t. R of t is t minus what will be the C of t expression, because when you take the C of t expression, that will be you have capital T minus t plus t e power minus t by 2. So we can get that it as we can cancel small t. Then if you find E of t, it is a t plus t e power minus t by 2. Here if you apply limit t tends to infinity E of t, then you will get it as capital T alone. The steady state error for ramp input is capital T, which is the time constant of the system. Then how can you can compare your input and output? So look at this response, input, and this is my output. So at some point of time, if you look at some point of time, so you have the difference between input and output. The difference between input and output is capital T. If the time constant is less, then transient response is also very less and your output will be almost nearer to the input. The steady state error will be very less. So if you have more time constant and it takes very long time to take the steady state, slowly it increases and will have a large gap between the input and output, and at any steady state condition, then input minus output will have a large gap, which is the time constant of the system. We can also find, as I said, E of infinity, but at infinity your R of t is infinity, C of t is also infinity, because we have the t term there. So before reaching to infinity, after the transient response, then we can find out what will be the steady state error. So that is also, it's called steady state error. So not that t is infinity is not the steady state error. After the transient response, any error is the steady state error, because the error is constant for longer time. So in that case, if you analyze, that will be the capital T. Summarize these three responses. What are the responses? The first response is impulse, second response is step, third response is ramp. So in the first response, we will have only transient, there is no steady state, that is impulse response. In the second step response, we have both transient and steady state. In ramp also we have steady state and transient, but the transient is very less. The most of the response is confined to your steady state. Therefore steady state initially we don't have, and steady state response increased, and steady state response is more increased in ramp. Where a transient, we completely transient, and some amount of the transient we have, the transient is reducing. So even if you take the parabolic input, if we try to find the response, so the transient part will be very less, then we will have only steady state part. Hence we use the parabolic input to find the steady state error or steady state analysis rather than the transient analysis.